Hello, this is Mr. Stansbury. I'm going to take you through the notes on exponential graphs and asymptotes. At the end of this, you should be able to say, I can determine whether an exponential function is increasing or decreasing, and I can describe the end behavior and identify asymptotes of exponential functions. Okay, so let's get into the nitty-gritty of this here. We've got a function is increasing if the y values increase as the x values increases. So for example, if you've got a graph that goes up like this or a graph that goes up like this, okay, so as x increases, y also increases. A function is decreasing if the y values decrease as the x values increase. So as we're going to the right on the x's here, as it's going down, that's decreasing. This is also going down, decreasing. Or as x approaches infinity, y approaches negative infinity, really there are some different examples here on this with the end behavior. That's just these two. It doesn't actually apply to these two graphs. We'll talk about that there in a little bit. Okay. An asymptote is a line that a graph gets close to but never actually touches. So an example is the halfway to the wall problem. So like if you stand say like 8 feet from the wall, and then you go halfway to the wall, now you're 4 feet. If you go another half, you're 2 feet. Another half, you're 1 feet. And as you continue to get closer and closer, you'll never actually get to the wall. The wall would be considered an asymptote, a value that you're getting really close to, but you never actually get to. Okay. Here also are some graphs with some asymptotes, and again, we'll take a look at those here in a little bit. End behavior describes what happens to the y values as x increases or decreases, okay, which we've done that before, but this is kind of to refresh your memory. Okay, if the end behavior approaches a constant like this here, a, then the graph has a horizontal asymptote at y equals a. So let's just say the y value is getting closer and closer to 6, but never actually gets to 6. Then there's an asymptote at y equals 6. Okay, we'll look at some examples that show that. And then domain is what the x values can be, and the range is what the y values can be. And we will look at some examples that deal with that. But this is just kind of some information that you're going to want to know as we go through the rest of this section here. Okay. All right. What I want us to do now is we're going to take a look at some exponential graphs. Okay. And this might look a little overwhelming at first, but you'll be okay. Now, please feel free to not draw all these out. This is just to show you the difference between all these, but I don't think drawing all these graphs is going to be super helpful for you. Okay. All right. So first graph we're going to show here is f of x equals 4 times 0.5 to the x power. Okay, so if we were writing that down just so that, you guys know, that just means that this x is up here as the exponent. We don't need to write that down. So just to take a quick look at that here, we are starting up here at 4, right? And since this is a decay model, that means this number is getting smaller and smaller. So this thing is coming down, and it's getting down here really close to 0, but never actually hits 0. So this decay model here is getting closer and closer to a number, but never actually gets to that number. So y equals 0 would be considered an asymptote on this one here. Okay. Now just to kind of show you a little bit different. So the exact same equation with plus 3. So basically it just takes all these numbers and shifts them up 3. So this comes down here, starts at 4 plus 3 is 7 is where it starts at 0 anyway. And then it gets down here and gets really close to 3, this 3 right here, but never actually gets to it. Okay. Now if we also look at, say, a negative 4 instead of positive 4, only thing that changes is that it starts down low and it comes up to this point. It gets really close to 0, but never actually gets to 0. And then if we take that plus 3, then it basically takes all these points here and just moves them up. So now it starts at negative 4 plus 3 is a negative 1. And it goes up and gets really close to 3, but never actually gets to 3. Okay. And just to show you here, like a 0.5, if there was something that was less than 1 out here in the front, Only thing that does is it makes it just like the slope is like it changes a little bit less, changes a little slower, if that makes more sense. So like this, if you'll notice here, it's pretty sharp decline and then it flattens out. This is already kind of pretty flattened out as we start here at 0 anyway. Okay? All right, let's get rid of those and then let's show you what happens. So these were all decay models. These 1.5s all mean that they're growth models. So if we look at the first one here, we start at 4, right? And then it's growing. It's at 50%. It's adding 50% each time. So it's going and it's going up and it's going up fast. Okay? And if we take the same one plus 3, it's taking all these points here and just moving them up 3, right? Because 4 plus 3 is 7 is where we're starting. So it just moves all those points up. Okay? These do not have what we consider to be an asymptote as we're moving to the right here because it's just going up to infinity. Okay? Now if we do -4, instead of it going up, now that -4 is being multiplied by 1.5 over and over again, and it actually ends up going down. Okay, and then if we did that plus 3, it means it starts up here higher. All these points are being shifted up 3, and it ends up going down like that. Okay? Okay, that's... Feel free, you don't have to write all that stuff down. You just want to know, just kind of get an idea of what's going on, and we're going to take a look at a couple examples here a little bit more in depth. Okay? So, but before we do that, let's take a quick comedy break.
So I really don't like happiness and touching right now. I think it's stupid. I think that's mostly why you getting on my nerves, sir. I feel like you holding her like she gonna run, and that's kidnapping. That's illegal, sir.
All right. Okay. Here's what we're going to do. We're going to take a look at some stuff, a couple of examples here, and we're going to do 5 things for each. State if the graph is increasing or decreasing, find the y-intercept, so forth and so on. So let's just do this. Let's just take a quick look at this graph. Now, you don't have to go through and sketch this whole graph, but what we can do is we can, what's going to, I think, make all these questions a lot easier is if you just sketch a quick little shot of this graph here. Okay, so let's do that. Okay, so if we plugged in 0, that makes this equal to 1. So we basically have 4 minus 1, just like what we were looking at on those graphs that we just had on the other page. So we do 4 at 0, we're at 4 minus 1, which is 3. Right? So that's at 3. And then this is a decay model. So that means that this graph is going to go, it's going to get smaller and smaller. And this here, this -1 here, is going to be our asymptote. Okay, so that -1 is going to be an asymptote if this is a decay model here. Okay, so what happens, that means is this graph is going to go roughly, it's going to go down like this, and then it's going to kind of start flattening out once it gets closer and closer to -1. Okay, so at least right now we've got an idea of what the graph looks like. And so then this way, it's just going to go up like that. Okay, so it's going to be a nice little curve like so. So now that we have all this info, that should make answering these questions a little bit easier. So A says state if the graph is increasing or decreasing. So we always look at it as it's going, reading a book, going from left to right. This is decreasing. Okay, and then part B says find the y-intercept. 4 and -1 is 3, so y-intercept is at 3, right? Because y-intercept is when x equals 0. 0 to anything to the 0 power is 1, so that basically takes this out, and you get 4 times 1 minus 1. Okay, find the equation of the horizontal asymptote. Going to be that number here, since it's going down to that number. So C, it's going to be y equals -1, right? Okay, state the end behavior, D. And you always do as x approaches -infinity, y approaches what? And then as x approaches infinity, y approaches what? So as we're going to the left here, as x approaches negative infinity, this thing's going up really fast. So that's going to positive infinity, right? And as this is going to the right, it's actually approaching this value of -1. This asymptote here that we got for C, that should end up being our end behavior for one of these. So as x is getting bigger and bigger, y is getting closer and closer to -1. Okay? And then part E, the domain and the range. Good news, domain for most of these, I really can't think of an example where it's not, but I'm sure there are some. Domain is going to be the funny looking R, which stands for all real numbers. Okay, domain is what the x can be. The range is what the y's can be, right? So in this case here, the range, it gets down really close to -1, but it never actually gets below -1. So I always think of the range. The range is the y's. What's the lowest it can ever be? -1. What's the highest it can ever be? Infinity. So if there's infinity, I always just leave it blank. And then if we do the lowest up to the highest, it's always going to be the less than sign here. So y is going to be greater than -1. So here's -1, and it's always going to be bigger than that, right? Okay. So there's our domain and our range. Okay. So that's all 5 parts of that. So let's take a look at this one over here. Let's maybe do this in a different color just to make it stand out a little bit more. So let's do this same thing. Let's do a quick little sketch of the graph here and see what we get. So at 0, we got 4 and -1. We're still starting at 3 here, right? Now, but this is a growth model, so that means this thing's going to go up like so. And then this thing's going to come down, make a little curvy thing this way. And so then this information here should give us a pretty good idea how to answer all these problems here. These 5 things. A, state if the graph is increasing or decreasing. As we are reading from left to right, this is increasing. Okay. Find the y-intercept. Okay, so the y-intercept on this thing here is going to be here at 3, right? It's 4 minus 1. Y-intercept equals 3. Okay, part C. Okay, so if we're looking at find the equation of the horizontal asymptote, if you look at this thing here, it's going to come down here, and it's going to get really close down here to -1, but never actually hit -1 like this one here. We should have put a little line in here. That shows the asymptote. That's this right here. Okay, so in this case here, we get y equals -1. This value will get really close to -1 as we get smaller and smaller, but it'll never actually get there. Okay, D, as x goes to -infinity, y goes to what? And then as x goes to infinity, y goes to what? So as x goes to -infinity, so as we're getting smaller and smaller this way with the x, the y is actually getting closer and closer to -1. And then as x is getting bigger and bigger here, y is going towards positive infinity. So then last part here, domain, it goes forever and ever to the left, forever and ever to the right, so it's going to be all real numbers. And then the range is going to be what the y's can be. So also in this case here, if you'll notice, look, it gets down really close to -1, but never actually gets there. So the lowest it ever is -1. And it doesn't have a big side because it goes up forever and ever and ever. So the range on this one is also y is greater than -1. Okay? All right, that's all we have for exponential graphs and asymptotes. If you have any further questions, please feel free to ask. Thanks.